Strings have many built-in methods in Java. They are diverse in their use and purposes, but programmers do not memorize all of them, if any. Anytime programmers work with string objects and a need arises for an action to be performed, they can reference it. The most common way to do this is by simply Googling Java string methods. A methods reference notebook is provided in this course that explains the most commonly used methods, but is not by any means a complete list. We will refer to it throughout the unit whenever there is a need in our programs to do so. The only one needed for the AP exam is the compare to method. However, you will find many others to be useful throughout this course. You probably use a string program in your daily life and don't even know it. Every time you create or log in to an account online, you are accessing a code segment involving loops and strings. Let's see if we can replicate it. We will begin with writing a program that will ask a user to create a username and password, then ask them to verify their desired password. The user is creating a login account with two inputs, a username and a password. Let's start with what that will look like. The code could look like this. Why are we able to use input again? Once the username is collected in input and then stored in user, we no longer care about the contents of input and can save new information there. So what is the next step? We must verify the password was entered correctly. What must happen? Well, here we ask them to verify the password by inputting it again. But is that enough? No. While we have stored an input into password and verify, we have not yet compared them to see if they match. Try it. What happens? Did you create an if statement using the double equals sign like this? Was the result what was intended? No, it was not. In fact, even when you typed in the exact same password, the output is always not verified. But why? You may be thinking, why can we not test for equality as we did before? For example, string s equals hello, string r equals hello, if s equals r, etc. In this case, the test will return true as in the past. However, the reason is not why you would think. Let's see why. Below are two legal declarations of strings which appear to hold the same thing, hello. Here we have string s equals hello, and here we have string r equals hello, but we've used the different new syntax. And then we test to see if they're equals, and the test returns false. But the reason is not what you think. Understanding the difference between primitive data types and objects, like strings, can be difficult. Let's take a look at what is happening behind the scenes in the computer's memory for a better understanding. The primitive data types we have discussed so far, int, double, char, byte, short, long, float, boolean, are stored in stack memory space. For example, let's create a primitive data type. Double cost equals 5.25. There is a memory space called the stack designed to house this data. So here we have stack memory space, we have our identifier or our variable name cost, and the value that it holds, 5.25. Storing data in the stack is relatively straightforward and what you would expect. Creating a string works differently, however. That is because all objects, anything not a primitive data type, are saved in a different memory space. Let's see how and why. When you create a string, you are really creating two things: a reference variable, which holds a memory address, and the actual contents of the string. So let's create a string. String team equals new string cougars. First, a reference variable team is created in the stack. We see that right here. However, it does not contain cougars. Instead, it creates and saves a memory location of cougars in a memory space called the heap. The memory location number is chosen at random by the computer in the stack. So here is our actual string, cougars, in the heap memory, and then here we store the memory location. If we were to compare two primitive values, so if cost equals cost2, the values in the stack are the same, 5.25. so the comparison would return true. When comparing two strings, say if S equals R, it's not checking to see if they hold the same value, but rather to see if they're pointing to the same memory location space, which they're not. S is pointing to this space here, and R is pointing to this space here. So the test returns false. You do not need to know much about how the heap works until you go farther into computer science, but it is good to have a basic understanding of how everything is connected. Saving information in heap memory allows us to do so much more with strings and other objects than what we were able to do with primitive data types in stack memory. So how do we avoid this issue and compare two strings as intended? Look in your string methods reference notebook at some of the various ones listed. Which ones do you think will help us in our login program to verify the password? There are two options, equals or compare to. Let's see how we can apply either to our if statement. This is what it looks like using the equals method. If password dot equals, and then we put verify in the parentheses, it'll print out that the account has been created and verified. Otherwise, it'll say your account is not verified. So here we have the variable holding the value of one string and the other variable holding the value of the other string, and it's going to compare the values of the strings. The other method's the compare to method. When using this method, characters within each string are compared to see which comes first alphabetically. So we have three different potential outcomes. If the outcome is a negative value, so if you put the string 1 here, the string 2 here, and you compare them, if the result is a negative value, that means that S1 comes before S2 alphabetically. If you get a positive value, that means that S1 comes after S2 alphabetically. And in the third case, if you compare the two strings and it equals 0 or returns a 0 value, then the two strings are identical. This can be used instead of the equals method. Which case would be of use to us? Let's use the compare to method. We want to know when compare to will equal 0 for the strings to be equivalent. So we have password here, dot compare to with a capital T, and then we put verify here. So these are the two variables holding the two different strings, and we want to see if it equals 0. If it does, the account has been verified, and otherwise, it has not been verified. Let's use a number line to visualize what's going on with the compare to method. If we place S2 at 0, we can see where S1 ends up in all three scenarios. If S1 comes before S2 alphabetically, the result will be negative, so S1 would be to the left of S2. So if S1 comes before S2 in the computer alphabet, you will get a negative value. If S1 comes after S2 alphabetically, the result will be positive, so S1 would be to the right of S2, as shown in blue. If S1 is the same exact string as S2, the result will be 0, so S1 and S2 would both be 0, as shown below in pink. Exactly what value you get as a result of the compare to method has to do with how far apart the characters in the string are in the ASCII table, or computer alphabet. You don't need to memorize the ASCII table, but you should know that numbers come first, then capital letters, and then lowercase letters. Let's walk through some examples. Let's say string goodbye equals goodbye with a capital G, and string hello equals hello with a capital H. Then we're going to use the compare to method, and we get the result of -1. The computer starts with the first character of each string, capital G and capital H. Since G comes before H in the alphabet, you can visually place it to the left of H on the number line, as shown below. Thus, the result will be negative. In this specific case, the result is -1 because capital G is one character to the left of capital H in the alphabet. So you can see we've placed this string at 0, and this string then is 1 to the left, so it's -1 as a result. In this example, all that we've changed is this G. Now it's lowercase. So in this case, lowercase g comes after uppercase h. That's how the ASCII table works. Uppercase letters come before lowercase letters. So the result is positive. In this specific case, the result is 31, because lowercase g is 31 characters to the right of uppercase h in the ASCII table. So we put this string at 0, and then this string is to the right 31 characters, because g, lowercase g, is 31 characters to the right of uppercase h. Once again, you will not have to memorize the exact ASCII values for any characters, but you should know that numbers come before uppercase letters, which come before lowercase letters. When you're dealing with objects instead of primitive types, you need to be careful about using the double equal sign operator. While equals will compare the characters in two strings, the double equal sign operator will compare the references. So if two different variables reference the same string object, which means to point to the same object in memory, the double equal sign will return true. For example, string A equals new string hello, string B equals new string hello. System out print A equals B will print false, since A and B are two different objects. However, if we set a new variable C equal to A, they will both point to the same object, and the double equal sign will return true. Two object references are considered aliases when they both reference the same object. You can also use the not equals operator to compare object reference values. If you want to check to see if a variable is actually referencing an object, you can compare it to null. Classes often have their own equals method, which can be used to determine whether two objects of the class are equivalent.